Alright, afternoon guys and gals. This is a quick update on this here 1500 watt generator that's going to be mounted to the little red diesel that I mounted to the back of my car a while back. So there we have the sprocket that's going to go on that red diesel. That's a 15 tooth. That's a 30 tooth. So we're going to be going 2-to-1 on this. And I'm making this video to also explain the wiring. Essentially, this is an 18-pole, 8-inch Samsung style washer motor. Okay, you can see the coils there. I rewound them with 19 gauge copper wire, 60 turns each on each coil, and it's still wired as a 3-phase BLDC motor. However, I cut them in half and I brought 6 wires out of each half, and they're numbered. See right here, it's 1, 2, and 3. So the goal is I'm going to wire each half of the motor to delta, and then this half to delta, and then we're going to parallel them together for essentially a double delta coming together. It's going to give us the max amount of current with a lower voltage. We still want, I wanted 50-60 volts at least. That's pretty good pressure to push the current through, and it'll be resistant to lowering down. And I wanted current anyway because for me current's important. I wanted to see if I could weld with this just like my big one. So over here, same thing. Both of these are wired the same way, same amount of turns, same copper gauge, everything. And these are mounted very strongly as far as the drum to the shaft. They're already keyway locked in. Originally these had 21 gauge aluminum, so we got all that crap off and put some good copper on there. Again, both of them are wired the same way. 6 wires for half of the motor, 6 wires for the other half. This right here is going to be a stiffener block that's going to help stiffen the torque coming off of that motor from the chain going into this sprocket. Okay, because this is going to be bolted to the frame, and then once it's all bolted down, including this, well, this will be part adjusted. So I got to readjust this since the Lexan that I mounted on all the sides tweaked this a little bit. You can kind of hear it, it's rubbing a little bit, so I got to fix that, get the rubbing gone just by adjusting the shaft, because I already know I had it aligned before. And I'll align it after it's bolted down. Then once it's aligned, I'll lock this down with it. So this is going to essentially hold in between the chain and the shaft right here. That way the shock from the chain shouldn't pull on that shaft too hard. Again, we're just going to parallel the 2 halves that are going to be wired in delta configuration. It doesn't really matter, and I think I described before the way I do it is I'll have it mounted down. I'll have these realigned where there's no rubbing. It's just nice and smooth, and I'll connect 2 of each coil pair together to the other coil. Like it might be this one connected to this one on 2, and then another one to 2 to 3. That might be what it is. We'll have to do that. Way I test it is I just spin it. There should be no cogging once you're in delta the right way. You will not feel any resistance, just like it's open wires. So I'll do that on one side, and then I'll do the same thing on the other half of the same motor. Get it wired correctly in delta, and then I will connect those delta connections together here in parallel, and I'll have to do the same thing again. Make sure it's clocked in the same direction. Once I have no cogging on one motor, then I'll switch to the other motor, do the exact same procedure. The hope is to get about 60 to 70 volts at 1200 RPM, because we're gearing 2-to-1 off of the little 3-horse diesel. So I want to spin 2600 RPM to get 1300 RPM on these. That's spinning fast. That's a little it's pushing it a little bit. These would like to spin around 900 to 1000 RPM. So we could technically take the torque up. We could give it a more inherent leverage, and we could go like a 2.3-to-1, 2.5-to-1. We'd be just fine. These generators would still be spinning just fine. And that's it's part of the build. You want the generator to have it real nice and easy turning off of your generator. You're giving the motor leverage over the generator. Now I want you to think about that for a second. We're giving the motor leverage over this. Okay, what that means you can decide, but I know that it's gonna go over real easy with the motor because it's not 1-to-1. Most generators are 1-to-1 because you do have lower losses directly coupled. There's no transmission loss, but guess what? I doubled the effective torque off of that diesel. So if that diesel was putting out, say, 25 Newton meters of torque, it's now effectively putting 50 Newton meters on this. Okay? And that's what matters because, yeah, we lost speed, right? The motor is spinning at 2,500 RPM, but I don't need the speed. I can't have the speed. So it's actually two wins. I need to cut the speed or I'm going to burn this up. The coil and the core is going to overheat if I try to spin it that fast and generate. So, because the frequency is going to be way too high. This frequency is already going to be over 200 hertz, most likely, probably about 240 at that 180 to 240, depending on how fast we spin it. So, got to keep that in mind. You don't want to exceed. You can go up to 400 hertz with transformer steel, but you're pushing it. It's going to get hot. The eddy currents are going to increase. So we want this spinning low. The ideal is that this is a low RPM, high current generator. That we've doubled the effective torque off of the diesel motor. Okay? So just wanted to make sure I covered everything. This is a nice little update. I'm going to try to do this and put this on this weekend. We'll see. I've got a lot of other things I've got to do. Hope you're having a great 4th of July. Hope this is interesting to you. I hope you do something similar. Great things to learn on. You know, junkyard parts are very good to learn on, man. Make something useful. Anyway, have a good day. Peace.